Transportation systems are increasingly becoming an indispensable part of human activities. The efficiency of these systems fundamentally affects the mobility of the workforce, the environment, energy consumption, and also foreign policies. Over the past few decades, intelligent transportation systems, or ITS for short, have emerged as a promising discipline that has garnered an increasing research interest. It has revolutionized the transportation sector by solving common traffic and vehicle-related problems. ITS can be seen as systems that deal with advanced data communication, information processing, traffic management, and also geographical positioning. The increasing complexity of ITS has imposed a necessity for high-performance modern hardware devices. One factor that amplified this complexity is the increasing reliance on machine learning techniques that are usually deployed in large-scale settings. From here stems the need for a thorough literature survey on modern hardware devices that are utilized in machine learning-driven ITS applications. A team from the Intelligent Hardware Research Group at the Electrical and Computer Engineering Department of Beirut Arab University conducted such a review in collaboration with Professor Hussein Mouftah, the Canada Research Chair in Optical Networks and Distinguished University Professor at the School of Electrical Engineering and Computer Science of the University of Ottawa. This work has culminated in the publication of a journal article titled Intelligent Transportation Systems, a survey on modern hardware devices for the era of machine learning. This paper was published in the Journal of King Saud University, Computer and Information Sciences, a Q1 journal with an impact factor of 4.011. A thorough review of the recent literature was carried out, which brings to attention the extensive research focus on implementing machine learning techniques on modern hardware devices to solve common ITS problems concerned with vehicle control and traffic management. A systematic protocol was abided by during the search for the articles to be surveyed. The academic search engines used were IEEE Explorer Digital Library, Science Direct, and Springer Link. Several combinations of the following keywords were used in the search process: intelligent transportation systems, traffic management, vehicle control, artificial intelligence, machine learning, deep learning, computer vision, hardware devices, onboard units, and roadside units. Finally, to keep the scope of the survey modern, only publications as of 2014 were regarded. Authors of the surveyed papers have selected different hardware devices that fall under three main categories: multipurpose devices, specialized devices, and hybrid devices. Multipurpose devices are defined as the hardware devices that are capable of performing diverse computational tasks due to their programmability. On the other end of the spectrum, specialized devices are those specifically designed and optimized for a desired application. And finally, hybrid devices are those combining the two aforementioned types to achieve results by bringing hardware-software co-design, pre-processing, and co-processing features to the table. The surveyed papers were classified according to these three categories. In addition, the choice factors that influence the choices of hardware devices and machine learning algorithms were identified for each article. The hardware device choice factors include performance, flexibility, power consumption, and resources. On the other hand, the machine learning choice factors are performance, accuracy, robustness, and complexity. The literature showed that the implemented models performed better on certain hardware devices than on others when it comes to time requirements of an ITS application. In this section of the article, the performance of the surveyed papers was evaluated first from an ITS perspective and then according to the three aforementioned hardware categories. The authors then presented a taxonomy of the ITS applications found in the surveyed literature, along with a taxonomy of the used machine learning techniques and modern hardware devices. Under ITS applications, the two main categories were vehicle control, which includes applications such as driver assistance, road detection, and vehicle analysis, and also traffic management, which includes traffic monitoring, traffic prediction, and traffic detection. As for machine learning, it includes 4 categories, the first of which is regression, which includes artificial neural networks. The second is classification, which includes support vector machines and artificial neural networks. The third is clustering, which includes k-means and fuzzy minimals. And the fourth is deep learning, which includes convolutional neural networks and deep neural networks. As for modern hardware devices, 3 categories were chosen. Multi-purpose devices such as microcontroller units and FPGA boards, specialized devices such as automotive-grade FPGA boards and GPUs, and lastly, hybrid devices such as FPGAs with microcontroller units and FPGAs with RISC processors. This has been the first video in a series of 3, presenting the paper titled Intelligent Transportation Systems, a survey on modern hardware devices for the era of machine learning. The links for the upcoming videos can be found in the description section.